Hello learners, welcome back to my channel Shraddha's Physics. In the last lecture of the classical dynamics, we have already discussed about the principle of virtual work, and in this video we will see Alemberts principle. In case of the principle of virtual work, when the system is in equilibrium and we consider that the force of constant is 0, then the virtual work of the applied force is 0. And that principle of virtual work, it deals with basically the static of a system of particle, and here we will see the dynamics, or I can say that when the system is in motion, in that case we will see the D'Alemberts principle. If you have not seen the last lecture of the classical dynamics, that is principle of virtual work, just go through it first, and I will share the link of the principle of virtual work in this video of the description box. Okay, let us start with the D'Alemberts principle. According to Newton's second law of motion, the force acting on the ith particle, I can write, just try to write with me. According to Newton's second law of motion, the force acting, according to Newton's second law of motion, the force acting on the ith particle, the force acting on the ith particle is here we can write Fi equal to dpi by dt. This is the rate of change of linear momentum is called as the force. So Fi equal to dpi by dt, or simply we can write it as pi dot. This is the pi, or let me write like this. This is the pi dot. Pi dot is nothing but the dpi by dt, that is the rate of change of the linear momentum, or simply we can write this equation as, this implies Fi, force on the ith particle, minus the linear momentum of the dot product pi dot, this is pi dot, that is dpi by dt, that is equal to 0, and here I equal to 1, 2 and so on up to n. And the physical meaning of this expression, that is Fi minus pi dot equal to 0, it means that when the system is in equilibrium, the force acting on any particle, it is equal to this actual force Fi and the reverse effective force pi dot. That is, let me write the physical significance of this equation. It means that any particle in the system, is in equilibrium under a force which is equal to the actual force, which is equal to the actual force Fi plus a reverse effective force, reversed effective force pi dot. Pi dot is a force, okay, effective force pi dot. So for a virtual displacement delta Ri, for this is pi dot, okay, pi dot. For virtual displacement delta Ri, we can write the sum over I equal to 1 to n Fi minus Pi dot dot delta I, it means that the work done, this is equal to 0. Since Fi minus Pi dot equal to 0, so we can write mathematically as the sum over Fi minus Pi dot delta I equal to 0. Now we can write this total force equal to the force applied and the force of constant. So let me write the total force Fi. This can be written as the Fi applied, the applied force plus the force of constant plus Fi. This Fi, small Fi is the force of constant and this Fi is the applied force. And if I will restrict ourselves, if we restrict ourselves to the system for which force of constant is 0, for which the virtual work of the, let me write, for which the virtual work of constant is 0, of constants is 0, that is Fi equal to 0, that is, let me write, the virtual work means this is your Fi dot delta I, this is your sum over Fi dot delta I, this is equal to 0. Then we can write in this equation, here you can see our total Fi minus Pi dot delta I equal to 0, and if I will substitute the value of Fi, that is force applied plus the force of constant, then here I am saying that, and also here is Pi dot whole into dot delta I equal to 0, and here I am saying that this Fi dot delta I equal to 0. Since this Fi dot delta I is 0, let me write the total equation. Here I am writing the whole equation. This is sum over I equal to 1 to n. In place of Fi, let me write first Fi minus Pi dot delta I, this is equal to 0. Okay, so if I will substitute the value of Fi, so that is the sum over I equal to 1 to n. Here this is Fi applied, the force applied plus the force of constant Fi minus Pi dot delta I, this is equal to 0, and here I am saying that in case of the virtual work, the force of constant is 0, or we can say that virtual work, that is Fi dot delta I is 0, that is the constant force is 0. So we can write this equation as this will be equal to sum over, this implies I equal to 1 to n Fi applied minus Pi dot delta I, this is equal to 0. This is called as the D'Alemberts principle. This is the representation of the D'Alemberts principle. This is what called D'Alemberts principle. So in case of Fi applied, simply here I can just drop this subscript A, or simply I can write it as Fi minus Pi dot delta I equal to 0. Let me write, if I will drop this superscript, now we can write it as sum over I equal to 1 to n Fi minus Pi dot delta I equal to 0. Here I am just dropping the superscripts. Here I am just dropping the superscript because there is no force of constant, or simply the total force equal to the force applied. So I am just denoting this total force as Fi applied, that is the force applied. Now if I can summarize the principle of virtual work and the D'Alemberts principle, you can see that in case of the principle of virtual work, that is the force applied dot delta I equal to 0. But here in case of the D'Alemberts principle, this is Fi minus Pi dot delta I equal to 0. This is principle of virtual work, and here this is the D'Alemberts principle. This is the basic difference between these two. Here this principle of virtual work, it deals with a system of particles which are in static, but in case of when the particles are in motion, then in that case here will come the pi dot, that is the again one force. Pi dot is the force. Pi dot means dpi by dt. That is the representation of the force. That is the D'Alemberts principle. Basically says that when the system is in equilibrium, suppose any force is acting on this system, then there will be a reverse effective force here also exist. So that this Fi minus Pi dot, or we can say that the sum of these two, that is Fi and the reverse effective, that's why we are giving a negative sign. The sum of these two, that is Fi and this minus Pi dot, this total sum is equal to 0. And here we have proved that Fi minus Pi dot delta Ri, that is equal to 0. This is all about your D'Alemberts principle. If you have any doubt, can ask me in the comment section. This is all for today. Thank you.